All right, so this last section, I warned you about, I told you about, I prepared you for, I told you what the end of all these chapters come up with, and that's this idea of modeling. So the last section in chapter 2 is exploring data, the quadratic model. So we did linear models in the first chapter, and we did linear regressions on the calculator. So this is very similar. So now we're going to be graphing different things that are quadratic. So the first thing I did was I just plotted some points myself, and I made 2 different graphs and I plotted some points. Okay. So notice, could I make a linear model? Is there a correlation? Let's start with that from last chapter. Is there a correlation here? Between the, is there a correlation here and is there a correlation here? First of all, do we remember what a correlation is?
No.
We said there was three types, right? We said we had there was such a thing as a positive correlation.
Yes.
That meant that as one variable increased, the other variable increased. And we said there was a negative correlation. That's meant that while one variable increased, the other decreased. And then we said that there was something that we called no discernible correlation, right? Okay, so what do we have here? Do we have a positive correlation, a negative correlation, or no discernible correlation?
Positive.
Positive. So it does. It tends to, one variable increases, the other one does. And so what would you think, how would you think could we model that linear, with a linear equation, like we did in the first chapter?
Maybe.
What do you think, Kelly?
Well, I think the one on the left you could, but the one on the right kind of looks like a parabola, like half of a parabola. It's really throwing me off.
Okay. So, you could sort of, I think what you're telling me is you could sort of,
Yeah.
you could sort I love it when the magic works when it doesn't. Okay. Okay, so I could use sort of a linear regression and model that linearly. It's not perfect, but we said in the first chapter that these aren't going to make all the points fall on the line exactly, or on the model exactly. The idea was to come up with a model that makes it so that all the points you have are closest to whatever graph that you make. So you could graph that linearly. You could make a linear model for that set of data, and it would let you make predictions in the future as things went up. It would let you do that. I'd have to have actual points to put those in to figure out my correlation coefficient. What's my correlation coefficient? What letter do we use?
A. C.
Sounds like a C.
Remember from the last test, I think you even put it on your test. What does R stand for? Correlation coefficient? I think that was like the one that everybody got wrong at the end of.
There's only 2 of us.
I think you both got it wrong, right? I put that on there to it was like exact definition out of the book.
Oh, the one that was supposed to be easy, but
Yeah.
got it wrong.
Oh, yeah, because that
So-
was throwing me off.
All right.
R
So
is definitely
we call R the correlation coefficient. What does R tell us?
No.
How good of a model we have. Okay? How well it fits. Okay, so what about this second graph here? Could I
don't trust it.
do a linear model for this?
Yes.
You say yes. What does Kelly say?
I don't trust it, so no.
For no reason
It
other than
looks
you don't trust it.
sketchy.
It looks sketchy. Well, could I do this?
It doesn't look as good as the other one.
No. Could I do it? Could I make a linear model for that to make predictions?
Yeah, if there's no more dots.
Sure, I could. But what Kelly's saying is, you don't think that would be the best model.
Correct.
So you could use a linear model. And for almost all, for all set of scatter points where you have a correlation, you could use a linear model. That's not always going to give you the best result. So I think what you're saying, Kelly, is that if I did a quadratic model that looked something like this, like a parabola, that would model that data better.
Oh, yeah.
Okay. So, and that's true. And so that's the first step with all these scatter points is to plot the data and then sort of look and sort of intuitively look at it and say, well, what model do I think fits best? And then the part you're not going to like is that the book's going to want you to make a couple different models. It'll want you to do it linearly and then quadratically and then determine, using your R correlation coefficient, it wants you to use that to see which one is better. So let's have a quick review. If your correlation coefficient, what can it be? What are the options?
What?
Correlation coefficient. It'll be a number. What are your options for the number? This is a review from last year.
Negative or positive?
Negative what?
Below 1.
Negative 1 to what?
Positive.
Positive 1. Good. I don't know if you just pulled that out or if
No,
you remember that. But it's negative 1 to 1. So you'll get a number. And basically, the closer that number is to 1, the better your model is. Actually, I should say it differently. In a positive correlation, the closer it is to 1, the better. If it was a negative correlation like this, the closer to negative 1, the better. The closer to the extremes, the better. If you have one that's closer to 0, that's a bad model. Okay, that means that
Wow.
it's not going to fit the data very well. Okay, so the closer to your extremes, negative 1 or 1, the better your model is going to be. All right, so that's all that is. So first of all, look, and then they're going to make you compare. So I don't have a lot here, but this is what I came up with. So a experiment was posed where they tested the gas mileage on a particular model vehicle based on how fast the vehicle was going. So for example, when it went 15 miles an hour for a sustained period of time, it got 22.3 miles to the gallon. And when it went 75 miles, it went 23.3 miles to the gallon, and so on and so forth. So find the model which best fits this data and use this model to determine the speed which will produce the greatest gas mileage. Okay, so what's our first step with all these models? Plot the points. So, and your calculators, you're going to make a table. So you're going to make your scatter plot. So that's the first thing to do is enter them into your table. And I haven't done this yet, so I'll do it with you. So we're going to enter these into a table, and then we're going to look at a scatter plot.
I don't even know how to do a table.
Okay, well, you go to the menu button, or Control N will give you something new, and go to Lists and Spreadsheets.
Oh, that's why I'm lost.
And then I'll type in speed. And then I'll put in all my speeds.
Does it go like that?
Yep. Huh? What did you say?
Said I want to go fast.
So then in my next column, my B column, I'm going to write mileage. And then 22.3. And double check yours as you go so you don't put the wrong ones in. 25.5, 27.5. Because as with all these models, it stinks when you do all the work and then realize at the end that you just typed something wrong. So.
Oh, but then you get to, it's like a sequel movie then. You know what's going on, you got some of the main characters.
That's true, but it's like a bad sequel. You ever go to a bad sequel?
Oh
No.
Where you think, why did they make another one?
It's like, why did the movie suck? And now you get to see an awesome sequel. Mr. Savior.
Oh, and look at that. I
I'll
already
be excited.
I already did what I told you not to do.
You
So
messed
you're
up.
saying Jurassic Park.
Yep.
Except I think Jurassic Park could have stood alone by the end of the movie. That's just me personally.
I don't even know Jurassic Park. They just did so many that got redundant.
There's only 3.
I think there's a fourth.
No, there's
Oh,
only
I'm
3.
okay. I just didn't
Yeah,
put.
you
I didn't go up to
probably
75.
It came out in 3D.
Yeah.
I mean, they put it back out in the beginning. The first one.
All right, I got it.
You
Now
got a
I'm
scatter
going to-
plot?
Yeah. No, what do I do after I got the table spreadsheet thing?
Give me a second. 28.8. 30.4. Okay. So you have this part where the table's done? Or you're still working on yours, Kelly? You got it?
I'm just changing something.
You got yours? Okay. So I go to menu.
Menu.
No, that's not what I want.
Insert?
Escape. No, escape.
Why? Go to graph.
Oh, wait, no. Was it insert?
Yeah.
Oh, yes. No, that's
No.
insert. No.
Table.
So I
Statistics.
go to this on button. This on button, not the menu.
On. Oh!
And then I go to down to the
Graph.
bottom here. Bottom one, add graph.
Add graph. And then you do,
Oh, yes.
go down to that function and you hit menu or something.
Menu. And then I put graph type.
Graph type.
I go to scatter plot.
Where's that at? You've
Graph
lost me.
entry / edit.
Oh, I had it. Scatter plot.
And my X was my speed. And my Y is scatter plot, but you gotta make sure your viewing window, which I'll use my new one, the
Menu.
I'll do that menu and zoom fit. I like this zoom fit thing. Oh, look at this.
Oh yeah.
I think I told you about that.
Good, very good. You got yours.
Oh boy.
All right, we'll finish this tomorrow. So that's step one. Is do a
Definitely
scatter plot.
quadratic.
You see, good. You can see good. So you can see the quadratic points. Very good.
Yeah. Yeah.
Read ahead and finish your sheets for tomorrow. The sheets I passed out.
Sweet. So no written